Have you ever nodded along in a meeting while somebody talked about coding, while you secretly had absolutely no idea what it really was? And not a vague idea, not like, oh, it's like telling a computer what to do, but actually understanding what a developer means when they say they're writing in Python, or why that even matters to you as a non-technical person. And most people haven't, and most are embarrassed to ask. But that ends today.
Hello and welcome to the Tech for Non-Techies podcast. I'm your host, Sophia Matveeva. If you're a non-technical founder building a tech product or adding AI to your business, you're in the right place. Each week, you'll get practical strategies, step-by-step playbooks, and real-world case studies to help you launch and scale a tech business without learning to code. And this is not another startup show full of jargon, venture capital theater, or tech bro bravado. Here, we focus on building useful products that make money without hype and without code. I've written for the Harvard Business Review and lectured at Oxford, London Business School, and Chicago Booth, so you are in safe hands. I've also helped hundreds of founders go from concept to scalable product. And now it's your turn. So let's dive in.
Hello, smart people. How are you today? It is beautiful and springy where I am, and so I'm in a fantastic mood. The sun really makes a difference. Anyway, I recorded this episode 4 years ago, and it remains one of our most listened to episodes of all time, and I think I know why. Because everybody, especially now, is talking about AI, but most non-technical people still don't have a clear mental model of what coding actually is. And it's not like anybody really explains it to us. It's like one of these things that somehow you're just expected to know through osmosis. And I think that's insane. But anyway, without the foundation of really understanding what coding is on a very basic level, the age of AI is not really going to make proper sense. So this episode is a quick introduction to a foundational concept that I think you really need to know in the digital age. And this is going to also make you sound really dangerous in a room full of developers, which I think is hot. Anyway, before you become super dangerous, can you please leave this show a rating and a review? That would make me really happy. So please put me into an even better mood. Okay, now let's get into it. Let's talk about today's topic, coding, otherwise known as programming. Now, unless you've been living under a rock, you would have heard these terms, coding and programming. But unless you're a developer or unless you've worked with a product team, you probably don't really know what programming or coding actually means. But the term is so ubiquitous, you probably feel embarrassed to ask, like, what is actually coding? What's a programming language? What's it do? It's a bit like, if you're at a party and you meet somebody and they introduce themselves and you end up having this really good, in-depth, maybe quite personal conversations, but you've totally forgotten their name and then it's just too embarrassing to ask, so you kind of pretend that you know what their name is. I find that this is how a lot of non-technical people think about coding. And, I know people who did not know what a coding language was, but still signed up to learn one. And non-technical professionals often make this mistake. And actually, I've made this mistake, so there's no judgment here. And it comes from, just basically feeling like you're so intimidated by your own non-technical status that you think, well, I'm just going to do all of the things, and I'm going to learn Python, and then that will give me clarity. But let me tell you from personal experience, it won't. Unless you know what Python is, why it matters, and how it fits into a broader technology strategy, and how that technology strategy actually helps a business grow, then learning Python is not a good entry point. It's a bit like, if you want to be a surgeon, but instead of taking a first-year course in medicine, you go straight to learning how to make a surgical stitch. And sure, that's useful. Surgical stitches are useful. But unless you have an idea of why the surgery is happening in the first place, you are not going to get very far. You'll just be doing your one little stitch forever. This is why you need a holistic view and you need to understand the basics. So let's go back to basics. First of all, you need to have two definitions clear in your head. What is data? And what is technology? let's deal with the first one. What is data? Data is literally any information that you can use to do something specific with. And that's not just high tech or finance. It's not just numbers, although numbers can be data, but it can also be any information. So it can also be photos. So for example, many of you probably have a shopping list to remind you what you need to buy when you go to the supermarket. So that shopping list is data. This shopping list data helps you make sure that you have a good mix of protein, vegetables, and treats in your kitchen after going to the supermarket, rather than just having 4 cakes and a bottle of vodka. And if all you have in your kitchen are 4 cakes and a bottle of vodka, you need a shopping list and, some thinking to do. So for your shopping list data, you make the decision ahead of time about what kind of diet and lifestyle you want to have. Then you take account of your preferences, and then you make a list that corresponds with your needs and preferences. And this data then allows you to take action when you're shopping. So imagine you are planning for a dinner party. So I'm literally going to have a few friends coming over for dinner in the next couple of days. So I want to buy food for the recipes that I'm going to be cooking, but also I want to buy some treats for myself, and I want to have flowers for my home. And so these are lifestyle decisions and these are preferences, but I am making decisions ahead of time about the outcome that I want, and then I'm gathering the correct data that I'm going to need to get that outcome. So now let's get to the second point. What is technology? Technology is the thing that you use to create, store, or communicate that data. So what is it in our shopping list example? So if you're making a shopping list, what technology have you used? Maybe you used a pen and paper. That is technology. I used the Notes app on my phone. That is also technology. And now, let's take a detour to ancient Egypt. Ancient Egyptians also had to go to the market to buy food. Do you think they could remember everything that they needed? Or did they get overwhelmed by sweet treats and booze when they got to the market? Just as we do today. I mean, literally whenever I get to Whole Foods, unless I have a list, I get very confused and I want everything. And so, did the ancient Egyptians also end up coming home with a bunch of cakes and wine, having totally forgotten the eggs? I bet they did. The shopping list is a problem that, humanity has been solving for millennia. So the ancient Egyptians needed shopping lists too. But paper hadn't been invented then. So instead, they used papyrus. Papyrus is a technology to capture and store data. And the reason why I'm stressing this point is that technology is just a tool to help you do things. As you can see from this example, technology evolves. As long as humanity has been around, we have been trying to think of new ways to capture, store, and transmit data. This is what the printing press was all about. This is what carrier pigeons were trying to help us to do. And the radio, and now the iPhone. Okay, maybe you're thinking, Sophia, you promised me a lesson about programming, and you're talking about pigeons in ancient Egypt. But darling, this is how we roll at Tech for Non-Techies. We are different here. But look, my point is that the more you see that technology has always been evolving, the more comfortable you will feel with the latest changes. And if you feel more comfortable, you will be able to be an active participant in technological changes rather than just having stuff thrown at you and think, well, I don't know what it is, I don't know how it's made, but I'm just going to nod and try to look very smart. So now let's get back to the 21st century. Today, most of us are not using papyrus to transmit and store data. And if you are, then please let me know, because that would just be really interesting. Instead, what most of us are doing is we're using our smartphones to transmit and store data. Your smartphone is a technology that consists of 2 parts, hardware and software. The hardware is literally the thing that you can feel. So that's the metal, the glass, and the plastic that you can see and that you can feel. That's the thing that you can hold in your hand. The software is what the apps are made of. Software is what is referred to as digital technology. In order to make software, a developer has to tell a computer what to do. And a developer does this via a programming language. All digital technologies are created by using coding languages to turn data into useful outcomes. And you might be thinking, okay, These are just lots of random words and I don't really understand what this means. So let's take this into the offline world to make this more clear. Imagine that you're at a party and, it's getting pretty late and you've had enough. All of the sexy people have gone home and the best champagne has ran dry and there's just plonk left and you've decided that there's nothing here for you. So you decide to go home. This is a wise decision. I applaud you. But your phone is dead, so you can't call an Uber. Thankfully, you're in the center of town, so you can literally just go outside and hail a taxi. So you hail a taxi and a taxi stops, but the driver doesn't have Google Maps. Remember, this is an offline world example. So your phone doesn't work, you're in a taxi, and the driver doesn't have Google Maps. The outcome that you want when you're in this taxi is to be taken home. So what do? You give instructions to the driver on how to take you home. So you have to share data with the driver. You give directions. So you can say, go right on the main road, then take the second left and drop me off at number 57. Now, in order for the driver to follow your instructions, you and the driver have to speak the same language. So for example, if you only speak Farsi and the driver only speaks English, you are going to have a problem. So how does this translate to coding? Coding is literally using a programming language to tell a computer what to do. Coding in Python is the equivalent of speaking English to your English-speaking taxi driver. Like English, Python is just one of the coding languages in the world. I actually read that there are 256 coding languages in use today, and even more have been developed. Just like the languages that we speak today, some coding languages have become obsolete. People don't speak Sanskrit and Latin anymore, but those languages have given the foundations to many of the languages that we speak today. It is literally the same in coding, but just the timeline is different. While Latin was spoken millennia ago, there are languages that were developed decades ago in technology that are no longer relevant. New programming languages are also being created today that will be in wide use in a few decades. Today, the most widely used programming languages are Python, Java, C++, and Ruby. But there are other languages that are also important. So for example, for mobile development, you might need Swift or React Native. Don't worry if you're getting confused with all of these. Given that there are 256 programming languages in use today, nobody knows how to use all of them. Also, nobody knows which one of those 256 languages is best for which particular task. So, these tasks, these languages, they are specialized. So there is nobody who literally can use all of these programming languages, just like there is no human who can speak all of the languages that are spoken on Earth today. But actually, there's another thing that I want to teach you. There is something more fundamental than coding languages that I want you to understand from this lesson. So let's go back to our taxi example and let's take it further. You're sitting in this taxi and your driver is driving you and you tell the driver to take a right. So you say, turn right. What happens? Pause and think here. What happens when you tell the driver to take a right? And, this is not one of those nightmare scenarios when the driver ignores you and takes you to a cabin in the woods instead of your home. No. This is a normal driver who actually just wants to take you home, get their fare, and treat you fairly. When the driver hears your instruction to go right, in the language that they understand, so you're both speaking English in this scenario, the driver's brain processes that information and sends an electrical signal to his or her hand to turn the steering wheel to the right. And thus the car turns. You see how between you giving this instruction saying turn right and the car turning, there is a deeper layer. There is the layer of interpretation in the driver's head, which goes from taking in the information and then turning it into a movement of the hand. But if you were in France instead of in an English-speaking country like I was yesterday, instead of saying to the driver, please turn right, you would say, s'il vous plaît, tournez à droite, which means, please turn right in French. Your driver would then have the same deeper reaction, input into the brain, which turns into an electrical signal from the brain to the right arm to turn the wheel, which means that the car turns. Exactly the same thing happens in computers. There is this interim layer between what a developer instructs the computer to do and what the computer does. Just like your brain needs to interpret an instruction within a split second before taking action, computers do this too. Just like our brains need instructions in a language that we understand, which we then turn into electrical signals, computers need to get instructions in languages that they understand to turn them into machine language. Machine language can then act on the programmer's instructions. If you're getting confused, just stick with me. Machine language consists only of zeros and ones. That's the deeper reaction that's happening deep within the computer. If you were to look at machine language, it would literally just be really, really long lines of zeros and ones. All computer code are instructions, which then turn into lots and lots of zeros and ones. Literally everything, every phone number, every phrase that you have on your phone, every instruction is literally just a combination of lots and lots of zeros and ones. This is called binary code or machine language. I was going to spell out my name for you in machine language as an example, but it would literally just be so many zeros and ones, it would just take too long and it would be really boring. So instead, I chose a number. Every phone number stored on your phone is coded as a combination of zeros and ones. Let's imagine that your phone number begins with 3 digits, 166. So your number begins with 166. In machine language, 166 would be written as 101001110. That is 4 ones and 4 zeros in a specific order, which is a total of 8 digits, to only describe the number 166. What this shows you is that writing machine language, which is also known as binary code, is impossible. It will take too long. It will be totally incomprehensible to humans. And so, when you're watching a futuristic movie or when you see stock photos of coding, you might see lots of zeros and ones. But I just want you to know that in general, this is not what your standard developer actually operates in. Normal developers aren't just writing lots of zeros and ones. Instead, they are using Python and Ruby and Swift or another language which looks much more comprehensible. So that binary code, those zeros and ones, are kind of what's happening in the deeper layer. In the deeper layer, that essentially takes that coding language, that takes a language like Python, and then translates it into some sort of action. If the last bit went over your head, don't worry about it. The most important thing for you to know is that coding is just writing instructions to tell a computer how to use data. Data are just information that can be cohesively used for an outcome, just like you'll use your shopping list when you go to the supermarket to get the outcome of having tasty and nutritious food to eat for the week. I want to leave you with a note that you don't need to learn to code to succeed in the digital economy, but you do need to know what coders do so you can be an effective collaborator, so you can speak the same language with them, and so you can co-create products. Because remember, technology is there to serve a need. Technology is a tool. What is a bunch of papyrus if people aren't actually using it to communicate something in order to get an outcome? What is a piece of paper unless it's being used to create some sort of instruction or to write down a memory, to essentially to do something with? Technology is a tool for businesses and for people to reach their aims. In order for those aims to be reached, the techies and the non-techies need to collaborate together. So essentially what you need to do to succeed in the digital economy is to become an effective collaborator, which means learning to speak the language of tech. Well, my dear smart person, that's it for today's episode. And if this is your first time listening, welcome to the Tech for Non-Techies universe. This is what we do here every week. We make tech legible for smart people who didn't come up through it, so then you can build your own tech venture and succeed in the digital age. If this episode gave you a clearer picture of how coding actually works, the best thing you can do for yourself and for the show is to hit follow so you don't miss what's coming next. And if you want to make my day, then leave a rating and a review on Apple or Spotify. It takes about 10 seconds and it genuinely helps the show reach more people like you. People who are smart, curious, and people who want to understand the technology that's reshaping every industry in the world. And on that note, Thank you so much for being with me today. Have a wonderful day, and I shall be back in your delightful smarties next week. Ciao.